Hello and welcome to the SRT411 Lab 4 demonstration. Today I'm going to be showing you how to upload bulk data to Elasticsearch and how to properly index them on Elasticsearch. Afterwards we're going to run some queries to show the results of the data found, and we're going to also start visualizing them using Kibana, and we're going to upload those visualizations on a dashboard. So for this lab, what I've decided to do was actually take two separate data sets. One is the global aviation fatalities by flight phase found on Our World in Data, and a similar one related to the same subject, whereas global aviation accidents by flight phase. What I decided to do was download both CSV files, combine them together to make a more comprehensive data table, and then upload that to Elasticsearch. So when I downloaded both CSV files and opened them up on LibreOffice Calc, as we can see, we have two similar data sets with similar information, whereas one pertains to the total amount of accidents that happen over the years during a flight phase, and the other one pertains to the amount of fatalities that happen during that specific flight phase over the years. So what I ended up doing was just combining these two data tables together by copying over one of these columns over here, or sorry, I copied over these columns from this table and I moved it over to this one over here. And just to clean up the data, all I did was get rid of the titles up top as a row. And this would be the final product of the combination. So there will only be years, this would be the fatalities, and these would be the accidents. Now before we upload the data to Elasticsearch and start visualizing, we first have to convert the CSV file to a JSON format. So in order to do this, I used a CSV to JSON converting Python script, as seen here. What I ended up doing was making sure that I first created the indexing name in the script as aviation fatalities to accidents by flight phase. I set it as type document, and I made sure that you're opening up in the correct folder. You're also going to make sure that you're going to do the output file in the same place, or you can specify another area, but I put it in the same area. Just make sure you name it as .json at the end. Now what I ended up doing was making sure that each each column of the document, the new one that has both datasets combined, are properly titled. So as seen in the document before, the first column, which would be line 0, would be the year. Second one would be en route fatalities, takeoff fatalities, etc., etc. Now to run the actual script, all we gotta do is run the command python3 and specify the CSV to JSON Python script. So if you press enter, it should run smoothly with no errors coming. As you can see here, if we do ls, the new JSON formatted file has been created. We can check the actual formatting of this JSON file by running the command cat fatalities to flight phase. We're going to specify the JSON file. We're also going to do head. We're going to do the first 10 entries. So as seen here, the way it's formatted, it first specifies the index that it's going to be added to, and then it's going to do the actual entry of the data table. So just before we upload the data table to Elasticsearch, what we're going to do is create a template so that future created indexes will follow a specific mapping format. For this, what we do, we create the command put template, and then we specify the template name. What we're going to do is also specify any index patterns that it's going to be attributing its mapping towards. So for this one, later in the video, I'm going to be creating the the index pattern aviation fatalities to accidents by flight phase. We're also going to specify the number of shards to be set to 1. We're also going to set the mapping properties. For example, the year column would be the type date. It's going to have a format YYYY for just years, since we're only dealing with each individual year. We're going to specify this as date rather than keyword because it makes it easier for us to look at specific intervals of time for each individual fatality or accident that happened. For the rest of the columns, such as en route fatalities, takeoff fatalities, and such, we're going to keep them just as integer, since all the data found in those columns are integer values. So it'll be easier for us to aggregate that data into sums or mins or maxes and medians and things like that. So we're going to actually run the command. Once it's acknowledged, all we got to do is run this curl post command. So we're going to specify xpost. We're going to specify port 9200, which is what Elasticsearch is running on. We're also going to specify that it's going to be a bulk type. Because we're dealing with a large data set, we need to specify bulk. We're also going to make sure that the content type is x-nd JSON, which is works well with large data tables that are being uploaded. And we're also going to specify the JSON file that we're going to be uploading. So you got to make sure that you're in the correct folder for this. And then just for my case, I'm going to put all the output into a text file for me to read later. So once you press enter, it says here that's been uploaded correctly. All the data has been uploaded. You can even check the upload text file, and it shows that each index has been properly uploaded, as there's no errors been found. And just to check that it actually worked, we're going to do the get command. We're going to specify the specific index, and we're also going to specify the mapping. If all went correctly, it should have the same mappings as specified in the template. And as you can see, they've been specified as integer, and year has been specified as date with format YYYY. So we know it worked. Next, I'm going to show you how to copy over data from an index using reindexing, how to give a index an alias, and also going to show you some basic JSON-based queries that you can run on Elasticsearch. So if you ever want to copy over the data from an index into a new index, what you can do is run the post reindex command. All you got to do is specify the source index, and you got to specify where the destination is going to be and what it's going to be called. Now, what's going to happen when you copy over, if you don't specify the mapping in the destination, the mapping of the original will not copy over. So let me demonstrate. So when I created the index aviation fatalities to accidents by flight phase -2, when you get the mapping, they're all set to keyword, but however the original was set to either integer or date. So you got to be wary of that when you're creating a reindex. Now, if you want to create an alias for your index, all you got to do is do the post _aliases action. What happens is that it will create an alias for that index, so you don't always have to call it by the full name. You can just do that alias instead. So if you run this and you specify the aliases of that index, it will be set to the newly created one. Now, some easy JSON-based queries that we can use on Elasticsearch is specified by doing the get command. You specify your index, you do the _search, and then you do $Q to specify the query equals and whatever query you want. So let's just say, for example, we want to see all the data that has been found in the year 1945. So we run this command. It will show us that in 1945 there were 184 en route fatalities, and another example would be 3 landing accidents. So another way you can get meaningful information just by selecting a single field is by doing this type of query. So first you do search. You specify the size to be 0 so you don't get any entries in the data table. You just get the specific information that you want. So we're going to specify aggregate. We're going to set the value to be max price. This way we get the max value of that entire column. And we're going to specify the field to be en route accidents. So if we run this command, we'll see that the value for the highest en route accident count is 51, and we can actually double check that in one of these files right here, the accidents file. So if we go to, I believe it was here, 1948, the highest is 51, which is correct. We can do the same thing for fatalities. It shows us the highest ever fatality for en route fatalities was 10,090 people. You can also double check that, which I would believe would be right here in 1985. So now that I've demonstrated how we can upload the bulk data and do some simple queries, on Elasticsearch, we're going to create the index pattern so we can start visualizing it on Kibana. So we're going to do a create index pattern. We're going to specify this index just for this example. We're going to click next. Now since we've specified our time field to be in years, we're going to specify the year column to be our time field. So we're going to create the index, and as we can see here, it shows us the type, format, and the name of the field. We can also view this in the Discover part or section of Kibana. As you can see here, this is for 2018, this one's for 2017, and it goes on and on. So the last thing I'm going to show you is the 4 visualizations I have made on my Kibana dashboard, how I made them, and how useful they are for analyzing the data for aviation accidents and fatalities by flight phase per year. So the way I have set up the mapping for my index, you can actually change between intervals of years, and the dashboard will change the visualizations alongside with it. So for example, right now, it's only taking dates from 2014 until the most recent year in the data table, which would be 2018. But you can also change this to be up to around 1940, and it should show you, yep, it would change up until about 1942. Now, just one clarification, Kibana has a weird bug that will not perfectly align up the years that you specified in the visualizations with what it has set up with its own timing. That being said, it starts from 1941 for all the data tables. The actual correct year starts in 1942. So you be aware of that. You'll also notice that in some intervals, such as here, it will spike down to 0 as if there was no events that happened during that year. That's also part of the bug. I'm not sure how to fix that, but I'll look into it. I think it has something to do with either time zone and or the internal clock of Kibana. So that being said, let's go into the first visualization right here, the line graph. So the first graph that I created on Kibana was the line graph. What I chose here to do was graph and plot the total amounts of accidents that happened per year for each individual phase. So for example, we would have the maximum amount of accidents that happen for an approach accident, an en route accident, initial climb, landing accident, and takeoff accident per year. Now, as mentioned before, the initial year is supposed to be 1942, but due to some bug with Kibana, it starts 1 year before. And there's also an issue in terms where certain years are skipped, and therefore the data is actually combined with some other years. So we have to take into account for that. Now, as we can see here, this is a pretty good visualization in terms of following the trends of each individual accident per year. However, it's a little clustered and it's a little hard to follow. So what we ended up doing is, since it's a year actually, since the time field is set to years, we can actually specify intervals of what years we can look at. So let's say, for example, we want to look at years between 2000 and up until 2018. So we'll do 2000 and up. And this is much more easier to analyze since it's a little bit less clustered and you could tell from where the data is going. So as seen here in 2002, again, the bug makes it say there's 0 landing accidents, but in actuality, if we go into the data table in the CSV file, as we can see in 2002, if this is landing accidents, so it should be the last one, there's actually 2 accidents. So what I believe is happening is it's picking up the value of 2003. So again, it's either 1 year before or it goes 1 year after. I have to figure out why it's doing that. Now, in generality, I think this is a pretty good graph just because it's good for following trends. However, it's not good in terms of comparing the severity of each one over the years, which is why I'm going to show you in the next visualization a better approach to that. So the next graph I'm going to be showing you is the aviation fatalities by flight phase per year. This one is an area graph, which is similar to a line graph, except it shades in all the empty space below the plots of a line graph. This makes it easier for analyzers to assess the actual severity between each different plot of a graph. So if we go into edit visualization, we can take a closer look. So we're going to actually do another data aggregation. We're actually going to go from, let's do 1970 till about 1975. So well, we can manually do that here as well. So we can do we'll do 1969 because it's 1 year ahead or before. We'll do 1979. So as we can see here, we can actually tell based off of the shading which graph has more intensity or more value compared to the other lines. So for example, we can tell that here the approach fatalities is much lower in comparison to the en route fatalities, which is much lower to initial climb, which is lower than landing fatalities over certain types of years, and takeoff fatalities is more during this specific year. Now, the only issue I have with this one is that sometimes when the data is so similar, as in the values are very close to each other in terms of like the amount of fatalities or amount of accidents that happened in that specific year for that phase of the flight, it will be a little hard to actually tell what is more intense. So that's why I recommend this for another purpose. If you want to actually get a better gauge for intensity of a certain data, we can actually use the gauge graph, which I'll show you next. If you want to show the severity of data side by side, what you can do is actually use the gauge graph in order to show the data, and it will also list you how severe it is in comparison to others. So here it's listed that 0 to 50 fatality is low severity, 50 to 75 is medium, and 75 to 100 or more is considered extreme. So, for example, in the year 2016, there was 65 total casualties when there was an approach accident. However, in the opposite side, en route fatalities in 2016 were at 171. This shows you in comparison for each year that there were much more en route fatalities compared to approach fatalities. This is because the actual flight phase in comparison is much more different, and therefore there's more factors that are involved. For example, the altitude of the planes during approach is much lower, and therefore there's less risk of a major cataclysm to happen in comparison to en route, which are much higher, and therefore there's less chances for the planes to actually make a safe landing or gain control of the situation if there was an accident. So the last graph I'm going to be showing you is the donut graph, which is a really good graph to use if you want to compare two different fields side by side based on the same x value. So if we go into this visualization, we're going to change the year to be 2014. So here we're just going to be showing you a simple comparison between aviation fatalities to their actual accidents for those years. So for example, in 2013 there were 75 total fatalities that happened during an approach. In comparison, there were only 3 total accidents that happened for approach landings during 2013. In comparison, in 2018, there were only 2 fatalities for an approach compared to the 2 accidents involving approaches that happened. Now this is really good. This is good for smaller ranges of data, such as between 2013 and 2019, because it's a lot less clustered. However, if you changed it back to the entire range of the data set, for example back to 1940, it becomes a little too much and it becomes harder to actually compare data between each other. So with that in mind, thank you for listening to my Lab 4 demonstration. Hope you have a great day.